We are now going to discuss sub and super classes, also sometimes referred to colloquially as child and parent classes. I personally like the following tutorial for an overview of subclasses and superclasses because it is not overly technical in its presentation. We will work through and expand upon just part of the example from that tutorial below. For a simple use case example that is kind of silly and easy to read, you may also want to check out this blog that I've linked to here. Now, imagine you have a class, Polygon, used as a template for all polygonal objects. It might look something like what we have below. You create your class Polygon, right, that's going to create objects, so we're following the standard conventions. And the way you initialize it is you have to say, well, how many sides is this polygonal object going to have? And then you're going to create the data attribute self.num sides, num_sides. And then if you ask it what it is, what am I? So I'm kind of borrowing this from the first kind of self-aware object we have. It's going to create a string variable, and this isn't an attribute that's stored anywhere, but it's going to create a string variable that says I am a polygon with, and it's going to concatenate to that string the number of sides cast as a string, and it's going to concatenate to that sides. So it's going to print I am a polygon with, and it's going to say however many sides it has. So that's what you're doing. You're just creating a geometric object, a very abstract one. You're saying, here's a polygon with, let's say, 3, 4, 5, 7 sides. Now, if you run this, you can then start instantiating this polygon object. You're going to pass it a number. And the idea is it should be an int, but you can imagine I'm not doing data type checking. You could add some if num, if is instance num sides int, then, or let's say not this. Right? If it's not that, you might return print something to the user and return, because you'd want to say this is supposed to be an integer. We don't have 3 half sides, fractional sides in a polygon or some float or something like that. I'm not doing that here just for the simplicity in the code. It makes the presentation much simpler, but it's obvious that there's some intended data types that should be adhered to when you're creating such objects. So now imagine, though, that you want to create classes rectangle and square. And you might think, well, geez, these are just special types of 4-sided polygons. I shouldn't have to start over and code all the things that are in a polygon for rectangle and square. This kind of goes back to what we were talking about in the very beginning in the first video about, like apples and oranges are different types of fruit. And so they inherit all the properties of a fruit, even though they'll have different values, potentially different characteristics, different colors, for instance. They're still fruit. Well, rectangles and squares are just polygons. They're just 4-sided polygons. And moreover, a square is just a special type of a rectangle. In that case, you can create a rectangle, and in fact, you should create a rectangle as a subclass of polygon. And you can create a square as a subclass of rectangle. Follow below and pay attention to the arguments in these class decorations. So this is again where it comes up where I say I used object for the parent class, polygon. Now when I create the class of rectangle, it's a type of polygon. So that is going to help with the inheritance, just understanding what it is. It's a subclass. So now when you do the initialization, I'm going to initialize it with a length and a width, because what is the point of specifying a rectangle if the length and the width are not specified upon initialization? So this is the polygon is the superclass, the parent class. So I want to initialize, I want this rectangle to inherit from polygon. So what I do is I use this super function, super with the 2 parentheses dot, and I'm basically calling the initialization of the superclass associated with the polygon, where it has the number of sides, and I'm setting it equal to 4. That's not something I'm passing here. I know that that's what it has to be because, after all, a rectangle is a 4-sided polygon. I shouldn't have to specify when I'm defining a rectangle that, oh yeah, the number of sides is 4. That's obvious. That is something that is just an attribute that you know has to be true for a rectangle. And it's something that should go into the creation, basically how it's going to inherit information from this polygon class here. The self.length and self.width are going to be defined by the length and width parameters, which can be different for a rectangle. They have to be the same for a square, which we'll come back to. Now, what do we do with rectangles when we first encounter them? We do things like compute the area, which is the length times the width. So that's a method here, and when we call that method, it creates a new data attribute called area, that you can access through the dot notation dot area that's equal to the length times the width. Notice you're always, all these data attributes, if you haven't picked up on this already, I probably haven't been emphasizing it enough, I access them with self.length, self.width. That's the importance of having the self here. It won't work if you don't have self there to begin with. And then I need to have self.length and self.width because that's how these variables were assigned upon instantiation of this object to these particular data attributes. Now, I can also ask my area, where I just say, like, what is the area like for this rectangle? Give me the area of this rectangle. And I want to try, here I'm using some things we've seen before, I want to try to print that data attribute. But as we've seen in the first video lecture, if I haven't called this method yet, then this is going to produce an attribute error. So if that did produce an attribute error when I tried to get my area, I am going to then call that method. Notice I do self.computeArea, that because it's accessible through the dot notation, that method. And I have the two parentheses because it's a method. And then that will create that data attribute, and then I can print it. So if I call my area, if I haven't called compute area yet, I will compute it. This attribute error will be raised, and then I will go ahead and call that the necessary method to remedy the error, and then I will print what the area is. I do something similar for computing the perimeter, where I also have a perimeter data attribute that's created in this method, which is 2 times the length plus 2 times the width. And then I have a similar type of function to just report, to print to screen what the perimeter is. And then I have a new method as well that's called myDimensions that will describe the length and the width of the rectangle. So let's just go ahead and run this. It's not an overly complicated conceptual idea of what this object is doing. It's a rectangle, and it has all these different methods associated with typical geometric computations involving a rectangle, computing area, computing the perimeter, that depend on the length and the width. And these are things you want to know, and they're going to be created as data attributes as they're computed. So it's a mix of method attributes used to create new data attributes, and it's a subclass of a polygon. So it's combining a lot of concepts, but hopefully in a way that seems fairly intuitive. So now when I create this rectangle that has length 2 and width 4, I'm going to call what am I. Now, what am I is not here. It's not in the rectangle method. It's in the polygon method. Or excuse me, the rectangle class. It's in the polygon class, which is inherited through this call right here. That is what now has inherited. That polygon class has been called, and it's creating this method with this polygon with these 4 sides. And so this is coming from the fact that it's a subclass of polygon. So I say, what am I? I'm a polygon with 4 sides. If I ask it for my area, it's 8 because 2 times 4 is 8. If I ask it for my perimeter, it says 12 because 2 times 2 is 4, and 2 times 4 is 8, and 4 plus 8 is 12. And if I ask it for its dimensions, it will report the length and the width as 2 and 4 respectively, which is what you see here, where I created this string that has this line return added to it. That's why it's across 2 lines when it prints it. Now here, I'm creating a class that is square that inherits from rectangle. And rectangle, as you might recall, inherits from polygon. So I again use that super function, which is then going to run the init function from rectangle, which itself calls the initialization function from polygon. In this case, a square only has one useful type of parameter to describe it, and that's the length of a side, because all the sides are the same. So in that case, the length is the length and the width is the length for the rectangle class. And then when I ask it for my dimensions, look at what I'm doing. Even though we've seen that you inherit the methods from the parent class, if you have a method or a data attribute that has the same name as the parent class, but it's in this child class, the subclass, I sometimes use parent and child, and I'm sorry if that's adding any confusion to this video. But if your subclass has a method or data attribute of the same name that is in the superclass, you are overrides the inherited method or data attribute from that parent class, the superclass. So my dimensions now, instead of saying length and width on 2 separate lines because they're different, I'm just saying length and width are equal to whatever the length is of this. So I'm just overwriting it right here. It's not overwriting, it's like an override in the saying just use this. So now if B is a square with length 2, and I ask it what is its area, It's 4. Now again, this is not showing up in square, it's showing up in rectangle. And that's where it inherited from. If I ask it for my dimensions, now you see this length equals width equals 2. That's using this one. It's not using it from the parent class. And if I say, well, what am I? This will still say I'm a polygon with 4 sides. Now we can also venture into the third dimension. So here I define a new class of objects, cubes. Now the face of a cube is a square. So we may choose to initialize the face attribute as an object. So I'm not going to really spend too much time on this, but just look at this class cube. This is not a polygon. A polygon is a planar object. It's a 2-dimensional object. A cube is a 3-dimensional object. However, when I create a cube, it just has an edge length. Just like square, there's one parameter that defines the entire cube. And that it's going to have a length given by edge length. And I'm doing this to show you that whatever this parameter is called, you don't have to have the data attribute be the same thing. I could do self.l for short if I want, but I like longer names, self.length. I'm also going to create faces from it that are squares, because the faces, which are the interesting geometric planar objects of the cube, 2-dimensional objects of the cube, it has 6 of these faces, and they're all squares, and they all have the same length given by edge length. So this is now calling, cube is not a subclass of square, but it's creating a data attribute that is itself an object. This is similar to how we saw the deriv attribute in a polynomial refer back to the polynomial class. So this is just referring to another class. And upon initialization, I'm going to go ahead and compute the area of the faces, and I'm going to call these other methods to just go ahead and compute things like surface area and volume. Notice I'm not calling things. I don't have methods to just report it, to print it. I would just access these through the dot convention, but maybe you want to create new methods about my surface area, my volume, or get volume, or get area, and it prints those to screen, similar to what I was doing, up above where I was printing information about it. Maybe you want that attached to this cube object. That's a good, suggested activity for you to do. So now when I run this and I create a cube of length 2, and then if I ask for surf area, notice surf area is a data attribute that comes from the compute surf area function. It's created there, and that's called upon initialization. So that is now 24. If I ask what am I, it says I'm a cube with edge length 2. That was calling right here, what am I? And the faces, though, those are squares. And if I say, well, what am I? The faces say I'm a polygon with 4 sides, right? Because the faces are coming from the square object. And the square object is inheriting from the rectangle, which inherits from the polygon, and it's going to say it's a polygon with 4 sides, the way we had it all designed. And volume, again, is a data attribute that's created when the compute volume method attribute is run. But of course, self.compute volume is doing that. So let's just go ahead, it's done upon initialization. We can see the volume is 8, which is 2 times 2 times 2, which is of course 8. So now there's a second activity. I'm actually not going to produce the solution here for you, but because it's really up to you. This is a little bit of your own creation. I want you to make your own classes and subclasses. You can build upon what we have here. Maybe try creating a superclass of 3D objects called boxes. Find examples or try to build upon, some by a simple Google search. Or even just get super creative with your own. Maybe a class of person. Like, what's the template of a person? That could have subclasses of adult, child, and baby. Get creative. Share your classes with the rest of the class that is working on classes, right? That made sense. This is really kind of a create your own adventure style activity. There are some basic things you must do though. Create at least one base super class and at least one subclass. Each super and subclass should have at least one data attribute and at least one method attribute unique to it. Instantiate at least two different versions of every class, super or sub, that you define. Demonstrate how to interact with your instantiated objects, just like how I'm showing interactions of my objects here. Have some useful code comments and markdown cells explaining what your classes involve and how your instantiations of them are demonstrating the various aspects of these classes, right? I produce these videos that provide commentary on what's going on. You're not handing in a video. You need to hand in code, something that's annotated effectively with code comments and markdown cells, so that I can read things about what you're demonstrating. And you might want to have those markdown cells kind of in between the various code stuff, so it's just easier to parse out. It's up to you how you want to design it, but that's what you have to do. And that's really the final part of this video, the second video for this lecture notebook.